Okay, so I just want to talk about now, after the Gorilla.sc, you run the experiment, and now you want to analyze the data. And you run the experiment in Gorilla.sc, you have tested 50 or more participants, maybe 100, 60, 80, whatever, in terms of the participants. Now you want to analyze the data. So how would you go about doing that? Well, first you have to download the data file, right? So for each participant, there would be a data file. And I'm sharing my screen in which that study, which I talked about earlier from PS360, yeah, there were pictures presented, uh, house, uh, in classroom, bridge, and then there were also words like justice, how it presented in a test. They had new words and new pictures presented, right? The other issue also was, well, another aspect with design was that some of the pictures are presented for 1 second, other pictures are presented for 3 seconds, and the same case held for the words, 1 second, 3 seconds. And we ran it and do a LST, where you could have 40 or 50 participants, but let's look at one participant data file. So, for example, here is my own data file here, and you can see in terms of the raw data file taken from Gorilla.sc, there's a lot of, say, data which you do not need, which you often find from data files, and data that you do need. So let's look at it this way. So, for example, you don't need event index. You need UTC, don't need that. So there's some columns which you do not need. So let's go. We do not need the Windows, if it was done on a Windows or a computer or desktop, we don't need that. And what we do need is the display, so we can go up to there and delete it. The participant ID is something that we do need. That wouldn't be deleted, but we don't have it in here because I ran it. But let's say we did, and we put a number there, right? So I'll just delete here, and then I'll delete up to here. And now we have the display, which is the test instructions, picture test trial, and then the picture test trial and the screen. This is important. Remember the display, which have the test instructions, right? So here you have screen and screen. But here, this is when it went to the space. So we don't need this row over here. We can take that out. We don't need the rows where there was a continue button pressed to go to the next screen during or it went to the next screen continue. So we have old, new, old, new, old. These are the responses. These are the rows we need. So let's go. What we can do here is we can filter. So we go data, filter, and which row do we need? Well, we don't need info begin. We don't need continue, continue again. So we'll just take out those rows. And so we'll uncheck here, response, uncheck response, and then we'll just delete this row, delete it, and voila. And I'll just clear, filter, and there's my data for one participant in terms of responses. So I need display, obviously. I don't need screen. I'll take that off. I don't need response. I know this is response. Now, some in recognition memory, we don't really care about reaction time. We care more about responses. But in my other class, PS362, we do care about reaction time. So I'll delete this part, and I'll go up to here. This might be interesting to look at reaction time. Recognition memory storage we do. So correct wasn't coded properly in terms of my responses. There is a way in Gorilla.sc to make it correct, make sure correct matches up. Now I delete this. I don't need that. So and it's a word test trial. I'll delete that. So what image was presented? Some students you do want to look at that. So maybe or some for participants, some images might be more familiar, and you could look at it that way too. Maybe this beach. versus this house is more familiar, and participants might be able to remember it better, even though it was only presented for 1,000 milliseconds, right? The familiarity could have an effect. So it would be nice to keep those image names over here so you can look at individual differences, or if the stimuli had a there might be an issue in terms of stimuli. That might be helpful for your lab 3 to keep that stimuli uh, information here, the labels, and look at individual differences and see if familiarity is an issue. So I'll keep that, and the randomization is done, and this is the correct response, right? So this is data for one participant. So let's say that was me, and actually it is me, and 101. Now, if there were some other participants, it could be 102 or 103, and it'll go up to 28 trials, right? And then, well, let's say we just copy this and change it a bit, and well, it'll be similar structure like this, but obviously you would have different responses. Like O would be here, and N would be here. Oh, I mean, sorry, O would be here, and you would, then O, and so forth, because each participant will have a different, and also the order of the words and the pictures would be different for that participant, right? And you can think about it going from 101, 103 to like 120 if there are 20 participants, or 50 participants going up to 150 and so forth, right? So that's your CSV. It's cleaned up now. It all looks good, right? So now we can go into, so you can, once you have all that, you obviously would look at the correct responses and match it up with the answers here. So the correct response is this, and what were your responses, right? So old, and then I said, oh, the correct response is new, but I said old. And then I could filter it in terms of data filter, in terms of the picture test trial, right? And if it was a target or a foil, right? And if it was presented for 1,000 milliseconds. And now you can see all these were old in terms of correct response. And I had two incorrect, right? So 8 out of 10. So I'll say 8 out of 10 old. So my measure here would be old target. That's one variable, target. And then I have 1,000 milliseconds. And this would be hit rate. So hit rate, and 8 out of 10. So that's a 0.80. So could do misses, and then you can do false alarms, and then you can do correct rejection, and false alarm also, right? And you would do it for each participant, but there's a faster way. You could do it in R. R enables you to do. Uh, if you know coding, the R is the statistical software, but it allows you to use scripts in order to get descriptive statistics. And Python can also be used in another programming language. All right, so that was that part. Now, if you want to look at the PID, now this is our data over here, right? PID, participant ID 101 to 143. So you have around 25 participants, and then the picture is presented, the word is presented, word, picture, word, target over here, picture, word. And then, so this one is picture present for 1 second, and then there is the target presented. I mean, this is, well, so what does this mean? So this is, pictures were presented during the study phase for 1 second. So for these pictures that were presented for 1 second during the test phase, this participant had 0.84 in terms of their hit rate. It's pretty good. So it was greater than 8 out of 10. Maybe this was 8 out of 12, 10 out of 12 maybe. In terms of 0.84. A picture of word 1 second target hit rate. This is hit rate to words that were presented during the study phase, test phase steady phase for 1 second. But all pictures and words were presented for 4 seconds during the test. Were presented for as much time as needed for the participant to enter in their response, right? And so here you have the miss rate, and then you have hit rate. Don't have false alarm rate here and the correct rejection rate, but that could also be looked. But those were for the foils, right? For the foils, you have new items that were never presented during the study phase, and then you just simply have to indicate, participant simply has to indicate if it's old or new. All right, so that's that. And then you import this into JASP, right? So JASP is here. So this is JASP, and you can see this, we have the practice data file, class data file, the PID, participant ID, so there are 25 participants. Picture, 1 second targets, word, 1 second targets, picture targets, and you get the proportion rate. So these are nice labels because now the uh, person who's analyzing data can know, okay, this is stimulus type, picture or word, and then it's 1 second, the duration, and test pool is target. All of these are targets actually. Now to do the analysis, you go to repeated measures ANOVA because we are only looking at two variables, right? Duration and presentation time at encoding and uh, the stimulus type. So here we have stimulus type. So I'll just say stim type. Well, stimulus type is fine too. So we have picture. Now notice the R code is also being generated. So this is interesting that R code can be generated. So picture and word and the duration. So presentation time. It would be better to say encoding time. And so this presentation time, and we can say 1 second, 1 second or 1000 milliseconds, and then we have 3 seconds. Now see picture 1 second, picture 3 second, word 1 second, word 3 seconds. So I can move it across. My dependent variable is hit rate. Picture 3 seconds, word 1 second, and word 3 seconds. Right. It's really nice that compared to SPSS, I can see my output in real time. So I have some significant results. Stimulus type is significant. Presentation time is significant. And there's an interaction between stimulus type and presentation time. Descriptive statistics, we want that. Partial eta squared, so we're getting that in. We don't want any model or post-hoc test because since we have an interaction, we would like to see the post-hoc test. So we'll do the Bonferroni test, Bonferroni test, and then this Tukey also. Now, I usually use Bonferroni and descriptive plots. You can move that over just to see more visually where the effects are present. Marginal means this is very important because it relates to each of your hypotheses. So if you want to look at stimulus type, for example, these are the marginal means. So it looks like for pictures overall, there's higher recognition compared to the words because we are only looking for accurate responses, not accurate inaccurate. So pictures are recognized better than words. That's obvious, irregardless of the duration. So we're not considering presentation time. Now, when we consider presentation time and encoding, the pictures and words that were presented for 3 seconds are recognized better than the pictures and words that were presented for 1 second, right? Now, you look at the uh, stimulus type times presentation time, and we want to look at marginal means. And so here we're looking at the interaction between stimulus type and presentation where it has. So picture 1 second, 0.848, picture 3 seconds, 0.99. That's a 0.6. Word 0.592, word 0.774. So what it looks like is that the difference between word 1 second and word 3 seconds is much larger compared to picture 1 second and picture 3 second in terms of recognition hit rate. And you can see that here. See, So if I move my cursor around this point, picture 1 second, 3 second, the difference in recognition memory or hit rate is much lower compared to 3 second and 1 second for the word. So that's one way to explain the interaction. How you could define an interaction. Other ways, there are also other ways to define interaction. So that explains the output of JASP in terms of the repeated measures ANOVA. Here you can see the descriptors. I really like JASP. It shows the statistical output and it's open source. We could also have done uh, Bayesian repeated measures ANOVA. That is now more often asked for in publications. Seems more dynamic than ANOVA because it can consider individual. It might also consider individual differences between participants. And here we have the data, we can bring that in, and then we have this. And then I can even export this to export the results to a PDF file, my OSF file. Yeah, so that's about it. Thank you very much. And so now we'll go on. I hope if you have any questions, please let me know. Thank you.